Anyone have the question about homework? Yeah, we can discuss right now. 有没有任何有问题的，就是 homework 上面，你跟你解答，你觉得，当然有些人解的方式不太一样，可能有没有仔细看。如果说有这种问题的话，事后再跟我再 check 一下。Okay, a lot of the students using, like for example, one of the problem for the homework 4 is this problem, right? And they're using the separation of variable to solve. However, this W here is not autistic. Okay, some of the students just mistake this W is autistic. This is not autistic. Okay, so some students using this later there's an exact solution for this kind of oscillation plate flow. Okay, and later we will discuss that. However, in our lecture note, WY is not autistic. Okay, so when you solve that, it's not autistic. Okay, so there's a lot of students doing that. So, is any question or any? No? Okay, everybody okay? About the homework answer and okay. So I will spend some time on this. So homework solution answer will be on the website. Okay, and you can check. If you still have a problem, sometimes it's your method is different from the answer. Maybe right, maybe correct, but you can discuss with me. Okay, but since I have to check a lot of homework, so every time I just check your kind of to see your method is correct, answer is correct. Okay, and any mistake, I may not be very careful about the homework. Okay, so there may be a mistake to correct the homework. Okay, if you find this problem, okay, just let me know. Okay. No? Okay. So next Tuesday, everybody should be okay, right? Okay. If you need any equation, okay, if you need an equation for solve the problem, it will indicate I will give you the equation on the question, okay. But not that maybe it's a very initial equation, but it's Navier-Stokes equation, for example. You have to simplify by yourself. Okay, I will give you the full Navier-Stokes equation, for example. And you know this is full Navier-Stokes equation, but by solving that, you may not need a so complicated or so full Navier-Stokes equation to solve the problem. You have to simplify it. Okay, but I will give you the Navier-Stokes equation if you need. Okay, you don't have to memorize. Okay. And I don't know, but we will see. Okay, next week. If you need any equation we didn't have, okay, we may post on the blackboard. Okay, if you need, everybody need. Okay, it's not the test your equation, memorize your equation. Okay, concept, physics, okay, behind the equation is more important. Okay. So try to familiar with, because this is the only time you will memorize and then try to keep very concentrate and try to understand everything. Once you go through that process, and later you will be more and more familiar with the. So we will continue our discussion about the conformal mapping or conformal transformation. Conformal transformation in Chinese is called 保角转换. Okay, then later you will see why is a 保角. 为什么叫保角？你们以前大家不知道为什么叫保角。Okay, so we have the Z plane. Okay, is in a very complicated geometry. Okay, right? Complicated body. So this is reality plane, right? This is most of the time we're dealing with very complicated geometry instead of flow over very simple geometry here. Okay. So this is our reality plane, right? This is like a flow over airfoil, flow over more complicated geometry. So this is the Z plane. So the conformal mapping allow us, 就是这个技术 conformal mapping, 允许我们 can have a mapping function. This is our mapping function, and mapping function can mapping zeta plane z plane to zeta plane. So any z plane point, for example, one point, one location over here, will through this function mapping to zeta plane in this function. Okay, that will be 1 to 1 corresponding. Okay, and then so in the z plane we have x and y like okay ordinary, and then in the zeta plane we have a c and eta, right? C and zeta. So this is c and zeta. Okay, c and eta. Anyway, so first I would like to fz, okay, this is transfer function or mapping function should be an analytical function, and this is the definition for analytical function. Okay, that means this fz is a differentiable, 它可以微分的 and this differential value is unique, okay, and existence. Okay, 这个微分的值是什么？存在且唯一。Okay, so I have to satisfy so-called Cauchy-Riemann equation. And so when this fz function is satisfied, this c and eta is satisfied by this two relationship, we call this, okay, f is analytical function. And analytical function, and the other ways to say is a differentiable. Okay, and this differentiable value is unique and existent. Okay, and here we introduce, okay, if you want to transfer from one z plane in xy coordinate to the so-called zeta plane, c and eta, okay, and then since our potential flow satisfy Laplace equation, this is the velocity potential. So in xy plane, in z plane, it satisfies the so-called Laplace equation. And we can do what? We can do this process just transform, try to convert or try to mapping xy to what? To c and eta. So all this effort here, this is mathematical effort here, just try to change xy to c and eta. And go through this process if you can follow it. And by apply this Cauchy-Riemann relation or equation, we can simplify this and this. Okay, eventually we will get this. Okay, eventually we will get this. So like I say, I change the xy to what? To c and eta already, right? So this is after I change, this Laplace equation should look like this in the zeta plane. Okay, so in zeta plane, as you can see, this should be equal to 0. Okay. However, if the zeta plane is the Laplace equation is here, right? So if you want to claim, 假如我们要宣称 okay, this one our Laplace phi in the zeta plane is equal to 0. That means this is equal to 0, right? We have to some condition here have to satisfy. This is our condition. This condition, this and this should not be equal to 0. Right? So except means excluded, right? Excluded this partial phi partial x, partial phi partial y, partial c partial x, partial c partial y, and through the Cauchy-Riemann equation you can change partial c partial x equal to partial eta partial y, and also the partial c partial y equal to minus partial eta partial x. Okay, except this term here cannot be equal to 0, right? If this is equal to 0, we cannot conclude this. Okay, 如果说这是等于0的话，我们不能说这个是等于0，这个意思是这样。So we have this additional condition here. So this additional condition here means when f prime, okay, this is all can be concluded. When your differential value f prime equal to 0, at this point we don't have this. Okay, we don't have this. So we have to exclude this point or exclude this f prime equal to 0. Okay, so our mapping function, when they do the differential f prime, if this differential value equal to 0, we have to be careful, okay, about this mapping, okay, because this mapping may not be concluded like this, so simple, okay. So we have to be careful about all this point, okay. 我们要特别去注意，当 f prime 等于0那些点是很例外的点。Okay, 当你做 mapping function 之后 when you do the mapping function, okay, from this plane to this plane, you have a mapping function, And this mapping function, you have to be careful about the f prime equal to 0 point. Okay, when f prime equal to 0 point, okay, this mapping may not be so simple or become very complicated. Okay, later you can see. Okay, so I think I will just kind of emphasize we just mentioned. Okay, we have the velocity potential in the z-plane. We would like to mapping to the velocity potential in zeta plane. Okay, so this is our velocity potential. Okay, to satisfy what? Satisfy our Laplace equation. That's our region. That's a potential flow, right? Potential flow, the Gaussian equation. So in the zeta plane, what happened? If we want to claim this one equal to 0, we have to have an additional condition here, except f prime equal to 0, right? We have to exclude this point. Okay, so that is one. And we will continue our, when you do the mapping from one to another one, for example. So as you can see, if I'm mapping z1, this point, okay, go through this transformation, mapping function or mapping transformation, it will transfer to the eta 1 point, zeta 1 point, and z sub 0 point will be transferred to z zeta sub 0. Okay, if I do that, okay, this is the limit. This should be the limited. It's not the this equal sign should be cancelled. Okay, they don't have an equal sign here. 这个等号要拿掉。We take a limitation of z1 approach to z2. Okay, so we do that zeta 2 minus zeta 1 z1. We do this limitation. This will be equal to d zeta dz, right? According to the calculus definition. 从微积分的定理，我们大概是这样。So in this one, zeta is equal to f, right? Because zeta is what? Zeta equal to this function. Okay, so this is what? The f dz, right? The f dz. Okay, so we have this relationship. And from this relation, I would like to give you the, okay, when you do the mapping, if you do the absolute value of this, 你把它取绝对值，绝对值就是它的大小， right? So you take a magnitude of df dz, right? This is absolute value of this, will be equal to what? Absolute value of this divided by absolute value of this, right? So this is absolute value of this and absolute value of this. Okay? And what's this meaning? What's the physical meaning for this? Okay, I just did one graph for you. Okay, here is a graph. Okay, so in your lecture note don't have this, but this I just want to make you understand better. So I have a z1 point here. Okay, and through this transformation, it will transfer to the zeta 1 point here. And this z2 point here will transfer to the so-called zeta 2 point, right? That's just I said. And we have this relationship, remember, right? This relationship. I think I make a mistake. This should be have a absolute value here. Okay. Change that. Our equation here. And got this. Okay. This should have an absolute value of this. Right? Okay, this is correct one. Okay. So we have this relationship, right? This relationship is the same as this relationship, right? It's the same as this relationship we have. Okay. So this we have this relation, and what's this physical meaning of this? Zeta 2 minus zeta 1. Zeta 2 is this vector, right? And zeta 1 is this vector. When this vector minus this vector will give you this vector, right? And what's z2 minus z1 will give you this vector, right? And what's absolute value of vector? The distance, length, right? The length here is s1 here. This is from here to here we have a length distance s1. From here to here we have the distance s2. So this is s2 over s1. Okay, you can written down this. Okay, so this will be give you what? Equal to absolute value of f prime z, right? So when you do the mapping, okay, you have a vector x1 length here. through the mapping to another data plane, this S1 will not be the same. Okay, will be enlarged or it will be run in or run out, right? Will be scaled. Okay, 它会被什么？被乘一个系数。Okay, and what's this number? This scale constant. Scale constant is f prime z. So if this is a point z and this is z coordinate, we just substitute this coordinate into and find f prime at this location. We know how much distance will have to be scaled. Okay, 这个长度需要伸长或缩短多少 ？Okay, through this. Okay, that's the physical meaning of this. Okay, so through the mapping, the length, the distance or length will not be equal or keep the same. Okay, 当你在做 mapping 的时候，那个向量的长度不会一样，可以吗 ？Okay, that's the physical meaning. First physical meaning here. Okay. Okay. So you can using this and then just drawing your z1, z2 and put s1, s2 and then written down for this equation should be equals s2 over s1 equal to this. Okay. F prime absolute value, right? Absolutely. Okay. Next. For this relationship, if you using so-called argument, what's the argument? Argument means what? The angle, right? Angle. If you have a complex number, so we get an argument for this relationship. So argument of df dz will be equal to argument of zeta2 minus zeta1 over z2 mod. And this one argument will be this vector. Okay, it will be equal to argument of z2 minus z1 minus argument of z2 minus z1. Okay, and what's the argument definition in the complex variable? We go back to here. Argument give you what? If this is angle, this is vector, right? This vector. If this is a vector, okay. So this vector argument of this vector will give you this angle alpha 1, right? And argument of this angle, okay, this is z2 minus z1's argument, right? Is equal to this alpha 2 angle, right? So that gives the angle. So that if you go back to this relationship here, this is alpha 2, this is alpha 1. So alpha 2 minus alpha 1 will be equal to of this, right? So I written here alpha 2 minus alpha 1 equal to this. Right? This is the relation we just get. So what in the physical meaning, what does it mean? 物理上面什么意义 For this map, in Z plane, we have angle alpha 1, right? And through the mapping to another plane, zeta plane, this alpha 1 and here is alpha 2. Alpha 1 and alpha 2 is equal or not? No, it's not equal, right? Alpha 2 and alpha 1 is not equal. However, alpha 2 and alpha 1 just what? Alpha 1 plus additional angle here. This is additional angle will be give you alpha 2. So this is alpha 1 original the angle like this. When they mapping to another plane, this just maybe this shift a fixed angle only. Okay, rotate a fixed angle, and this fixed angle is this. Okay, so as you can see, this is alpha 1, and when you mapping to the zeta plane, this alpha 2 just original is here, right here, and they just rotate a fixed angle. How much fixed angle? This is fixed angle. Okay, this is fixed angle. Can you see that? 它会转一个角度而已，这个角度跟什么有关？跟这个 f prime z, this z is corresponding to the coordinate for this point, right? So when I evaluate this point, okay, this point, I take f prime of this point, and for this one, I find its argument here, okay, and this argument will give you the angle difference between the alpha 2 and alpha 1. OK， 它就转个角度，转一个固定角度。OK， 在某一点上面，转过去它就转一个固定角度。 固定的一个 shape 的一个角度。Okay, and let me ask you a question. Okay, if I have a two vector, these two vector, right? And these two vector, the angle in between these two angles is beta 1. When they do the mapping to the so-called zeta plane, so these two vector, this vector will mapping to this vector, and this vector will mapping to this vector. Okay. How about beta 2 here? Beta 1 and beta 2 should be the same or different? The same. If the same, raise your hand. No? No? 1, 2, 3. More and more. No. Okay, you didn't realize, right? You didn't realize why is it the same? Should be the same. 为什么 should be the same? Can anyone give me the answer why it should be the same? This beta 1 should be the same as beta 2. 有没有任何人知道的？赶快讲出理由来。我们刚刚随便举一个 vector, we just raise a vector, right? We just using arbitrary vector. This vector will just rotate a fixed angle, right? So this vector, when they're converting, it just rotate a fixed angle, right? And this vector also mapping also rotate a fixed angle. Both of this vector only rotate a fixed angle. Beta 2 should be equal to beta 1, right? 它只是做这样子而已嘛。对 ，angle 本来是贝塔 1， 然后到另外一个边就变这样，这意思是这样。所以这 why this transformation called conformal mapping in Chinese we call 保角转换。OK， 它 preserve 那个角度。OK， preserve 这个。When you have angle，OK，when you have angle beta 2, beta 1, through the mapping, this beta 1 and beta 2 will be the same. Right? So we keep the angle between two vectors is the same. So if you have the L4 here, okay, for example, you have L4 here. Through the transformation, your L4 here will be the same. Okay, this cast will be the same. In the zeta plane and z plane. You'll see later. Okay. So that's this one give you the information, and this will be give you why this so-called conformal mapping. Conformal means the shape is the same, right? Conformal mapping shape is the same. 形状一样，什么形状？那个角度。The angle. Angle through the transformation, the angle will be keep the same. Here is the conclusion. So when you do the transformation, there is a local magnification factor, df dz absolute value, and a local rotation angle, argument of df dz, right? Through this transformation. And as you can see, this magnification factor, if the df dz is equal to 0, what happens? Shrink, disappear. So it's undefinable, right? So the df dz equal to 0, like here. If the f prime equal to 0, what? It's undefinable. 就不见了就没办法定义了。So we will not allow this happen, right? It will not. One thing is have the vector there, and then through a transformation, everything disappear. Wow, like a black hole. Okay, 就是物理上面有，我们在 in the physics, in the aerodynamics, or this is in the fluid mechanics, we don't have this kind of so-called strange attractor or anything. Would be anyway. So here we are not allowed. Df dz is equal to 0. So df dz should not equal to 0. It's not equal to 0. So df dz equal to 0, we call this is the critical point. So we have every time when you do the mapping. 每一次我们就去检查这个 mapping function, we have to check where is our critical point. Okay, we have to know where is the critical point. Okay, critical point we have to be special take care. 我们要特别就是处理，就这么简单。Okay, so df dz equals 0. All this point corresponding to z point corresponding to df dz equals 0. Okay, and this will be so-called critical point. Okay. So anyway, so since our mapping function I already announced, right? This mapping function is analytical, right? Analytical at the beginning, right? At the beginning of this fz is analytical function. Okay, so that means f prime z is what? Is differentiable, right? And this f prime z, the variable of this f prime z is what? Is unique and existent, right? 存在且唯一。对不对？它只有一个值 ，OK， 而且是存在的值 ，OK。So here we have the fz is analytical function. So f prime z is independent of direction along any which is evaluate because it's unique, right? If you evaluate from the different direction, should be equal since it's unique value. Okay. So the O curve, if you have any curve passing through this point, okay, the magnification will be the same. Okay, will be the same ratio. This should be the absolute value of this. Okay, magnification factor should be absolute value of this, right? Okay, and the relative angle. What's the relative angle? 相对的角度就是这个贝塔 2, 贝塔 1, right? This is beta 2 is this vector relative to this vector. We call this relative angle. This relative angle through the transformation should be what? Should be keep the same, right? So relative angle and shape should be preserved, right? That's a physical meaning of this. Okay, so we call this kind of transformation has special terminology for this. 我们特殊的术语，这种特殊的一个转换，我们称为叫 conformal mapping. OK， 中文我们把它翻作保角转换。你知道为什么是保角 ？OK， 以前都不知道，我念到大学我也不知道为什么叫保角，念到研究所我也不知道为什么叫保角。OK， 教了书才知道，抱歉。OK， Anyway, here is so another issue here. We have all kind of source and sink and compressed velocity, right? All this potential flow in z plane. How that change? 我们以前不是学有什么 compressed potential, compressed velocity. We have a source and sink and doublet. Okay, all this spectral flow. How about through the transformation? What happened to all this? We can check. Okay, effect on the compressed velocity. Okay, 当你做转换 when you do the transformation, what happened to the compressed velocity? So compressed velocity Wz is the definition is df dz, right? It's a compressed potential differential of a compressed potential Fz. Okay, this is capital F. Okay, capital F means the compressed potential. Okay, small f means what? Mapping function. Okay, just make a difference. Okay. So df dz we can do the so-called variable. Okay, change variable df d zeta and d zeta dz, right? And df d zeta become what? Become omega zeta, right? And this d zeta dz is what? Is a df dz because zeta is through the transform mapping function f. Okay, so this zeta equal to fz, right? So this is a df dz. So according to this relationship, what happened? Our compressed velocity will be scaled, right? The transformation will be magnify our velocity or rotate our velocity, right? Because this has argument, okay? It have a magnitude with argument, right? 一个这个函数有一个什么？有一个长度的 scaling， 也有一个角度的变化。Okay, so our velocity, the velocity field in z plane and velocity field in what? In the zeta plane will not the same. Okay, the angle will change, the magnitude will change. Okay. Okay, so this is you should know that. Okay, another issue is what? how about all this basic singularity? What's the basic singularity? We have a doublet, right? We have the source, we have a sink, we have a circulation, and what happened to all of this? So we can